Hello everyone, I am Dr. Shivam Singh, Assistant Professor in the Department of Electronics and Communication, ABES Engineering College, Ghaziabad. And today I am going to deliver a lecture on PN junction diode. So here is the outline that includes introduction, working principle, PN junction diode characteristic, VI characteristic, then the comparison between VI characteristic of ideal and practical diode, applications and references. Now moving to the introduction. So a diode is two-terminal electronic component that permits current flow only in one direction. And here you can see the symbolic representation of a PN junction diode, in which you can see here is the anode that corresponds positive terminal, and here is the cathode that corresponds negative terminal. And here in green color you can see the arrow, green color arrow that shows the direction of current flow. That is unidirectional current flow. As I discussed, that diode allows current only in a one direction. Now you can see the creation of a PN junction. So when you combine a P region and N region, then a junction forms called PN junction. You can also see in the points mentioned here, a PN junction is created by combining a N-type and P-type semiconductors. In the second point, it says in P region, intrinsic semiconductor is doped with trivalent impurity. Here, trivalent impurity means what? Boron, aluminum, etc. And in the next point, in N region, intrinsic semiconductor is doped with pentavalent impurity. Pentavalent impurity means nitrogen, phosphorus, and etc. Now moving to the working principle, then the first point says the N region contains large number of electrons, whereas P region contains large number of holes. So you can also see in this diagram that I have mentioned, you can see the P region and N region. So in N region, in P region, you can see the large number of holes, and in N region, you can see the large number of electrons. So in the next point, you can see free electrons from N region diffuse into P region and merge with holes. Similarly, free holes from P region diffuse into N region and merge with electrons, and hence left with positive and negative immobile ions. Immobile ions means what? It will not move. Okay, so you can see positive and negative immobile ions in P region and N region. You can see here. Here in P region, these are immobile ions, negative ions, and in N region, these are immobile positive ions. Okay. So in the last point, you can see due to accumulation of immobile positive and negative ions near the junction. Here junction means what? When you connect when you combine P region and N region, then a junction is formed in the form of depletion region. Here I have mentioned depletion region in red colored curly braces. You can see here. This red colored curly braces you can see, and in this region corresponds depletion region. So in depletion region, you can see immobile ions are there, positive and negative, both. So now you can see that the internal mechanism of a PN junction diode. So you can see here we have supplied a voltage to the PN junction. Then you can see, or you can better understand with the following points given here. When the diode is forward biased, electrons from the N region are pushed toward the P region. Likewise, holes from P region are pushed towards the N region. So here, if you supply voltage to the PN junction diode, then electrons will be pushed to P region and holes will be pushed to N region. And in this way, it will cross the junction. Junction I have mentioned in this red color arrow, you can see here. This is the junction. So electrons and holes will be crossing this junction. So in the continuation of that, you can see at a certain point of time, the depletion region collapses and there is no opposition to the flow of current. Means what? Means when you continuously apply this voltage, then at a particular time, after some time, when you are applying voltage, then this junction will be overlapped and electrons and holes will be easily come across it. So in the last point, it says, hence, large number of electrons and holes will cross the junction, as I told, and make the current to flow from anode to cathode. Okay. So you can see the internal mechanism with the first diagram. And the equivalent circuit for this first diagram is shown here. You can see a diode connected with the resistance. So this is the equivalent circuit of the PN junction diode. Now, PN junction diode characteristic. So you can understand with the help of these two diagrams. So talking about the first diagram, before going to discuss these two diagrams, we need to know the forward bias and reverse bias conditions. So talking about forward bias, so it says that when you connect the anode terminal of the diode with the positive voltage supply and cathode terminal of the diode with the negative voltage supply, then diode will be in forward bias. And when the diode will be in forward bias, then it will be treated as short circuits. Means your diode will be treated as short circuit. And in the reverse bias condition, it says when the negative terminal or cathode of the diode will be connected to the positive voltage supply and positive terminal, that is anode of the diode, will be connected to the negative supply, then it is said that the diode will be in reverse bias condition. And under this condition, the diode will be treated as open circuit. You can see in the second diagram. So this is the difference between forward bias condition or forward bias and reverse bias. Now moving to the VI characteristic. So this is the VI characteristic of a particular practical diode. You can see here. So see the diagram here. Here you can see it is plotted between voltage and current. So if you apply forward voltage here, forward voltage, then you can see due to when you apply some finite amount of voltage, then up to some certain voltage level, the current is not responding. But after some finite amount of voltage, that is called cutoff voltage, beyond that cutoff voltage, your current is increasing. So this is the forward voltage characteristic of a practical diode. Whereas if you make the connection in reverse bias condition, then if you apply negative voltage to the diode, then there is a small amount of current flowing while in the reverse bias condition. Then at a certain point, you can see that is called breakdown voltage. After that voltage, the reverse current is suddenly increasing. So this is the typical VI characteristic of a practical diode. Now talking about the diode current equation, then you can see ID equal to IS in bracket e to the power QVD divided by NKT minus 1. So here ID is diode current, VD is forward voltage, IS is reverse saturation current. What is reverse saturation current? When you connect your voltage in a reverse bias condition, then there is a current generating called reverse saturation current. Now this is the VI characteristic of a ideal diode. Previously, I have discussed the VI characteristic of a practical diode. Now, ideal diode characteristic you can see here. Here you can see when as soon as you connect your diode is in forward bias condition, then without taking too much voltage, the current is increasing. Means there is no cutoff voltage in the case of ideal diode. As I have mentioned also, see here, there is no cutoff voltage in ideal diode. So here you can see the symbolic representation of a diode, and if it is connected in forward bias condition, then it will act like a closed switch, and when it is connected into reverse bias condition, it is acting like a open switch. So this is the case for ideal diode. Now a comparison has been made. You can see it is the VI characteristic. The first diagram corresponds to the VI characteristic of an ideal diode, while the second one is the VI characteristic of practical diode. So you can see it has no cutoff voltage. In the case of ideal diode, it has no cutoff voltage. As soon as you apply voltage, then current is increasing. While if you see in the practical diode case, then there is a cutoff voltage for the practical diode, and after some amount of cutoff voltage, or you can say beyond that cutoff voltage, your current is increasing. So this is the major difference between the characteristic of an ideal diode and practical diode. Now moving towards the application. So although there are lots of application of semiconductor diodes, but here I have mentioned few of them. So you can see the first application is PN junction diodes are used as rectifiers to convert AC into pulsating DC. You can also use diodes as switch in electronic circuit. And the third one is we can use semiconductor diodes as a LED to emit different colors. You can also use as a photodiode. And semiconductor diodes can be also used as detectors to detect audio signals. And these are the references that I have used to prepare the entire content. Thank you.